Okay, so this is the file I'm going to share with you. A bit smaller. Okay, so this is the data file I'm going to share with you. So I'm going to give you data and you're going to paste it into this file here. It's called the K5 template version 5. Okay, it's 2 sheets. There's this sheet here, and you're only interested in box A1. That's where you're going to paste the data I'm going to show you. And then there's this sheet here, and this is where the data appears. Okay, so basically what you're doing is you're taking data from an exercise test and we're going pasting it in to this sheet here, right here, and then this does some kind of processing in the background. And I'm interested in all this data here, this kind of peach color, green color, and red color, and blue. Okay, and it's going to make one graph for you as well here. Okay, so the data files are, I'll send you a few along with a copy of this, right? So data files look like, sorry. So the data files look like, so I've done up to 95 here, so I'll go for, let me see, I'll do 96. So these are the files. These here are the files that I've yet to do. Okay, there's a few more I've got to add in there, so these are the ones I'm working on for the time being. What I'll do is I might give you, say, a few of them in the 20s. Okay, I'll give you these ones here, 121 to 127. That'd be great if you got a few of them done. But anyway, this is how you do it, right? So you open up this file. So this is kind of your working file. Okay, I say the data file you're going to use. Okay, and basically what it is it's a printout from or it's an extract from an exercise test. Sorry, has this been recorded on the screen? Hang on, let's have to pause. Okay, so I just want you to look at this screen here. Just wasn't recording there for a second. So this is the data file. Before you paste it in, you're going to paste all this data into the first sheet on the data processing file I gave you. Okay, so the things I want you to look at here are, in some of the files, just the way the data was extracted, there's a few additional kind of columns of data here, and if they go into the other sheet, then it kind of messes everything up. Okay, so you just need to be careful of that first. So there's 3 columns in particular I need you to pay attention to. And what I'll do is I'll send you a photo of the ones that you need to be careful of because they mess up everything. So you need to check columns X and Y. Okay, so sometimes there's heart rate and VO2 for heart rate in there. If there is, you need to delete them. This one is fine. FE, the fraction of expired. O2, fraction of expired. CO2, that's perfect there. So that's X and Y you need to check. So long as it's FeO2 and FeCO2, that's perfect. Okay, the next column you need to check is BW, which is here. Okay, and BW should be O2 costs, so that's absolutely fine, so that's perfect. And then you need to check CF, and CF should be tidal volume to inspired time, and that's absolutely fine as well. Okay, and then you also just need to confirm that dyspnea and leg pain are CG and CH. And we can see here they're not, and that's because this real load is after appearing in some of the later tests. It's just something that was set up on it. Okay, so you can basically Control right click, delete that column, so that now we have CG in dyspnea in CG and leg pain in CH. So it's perfect now to paste it in. So the thing to do is just click that corner, then right click, copy. Okay, that's all your data. Then go back to this first sheet, and in A1, just right click and paste. And that's all the data gone in. Okay, so then you go over to the other sheet and then have a look at this here. And you just want to make sure that all of these are the same. So we've pasted over everything in the second row here. Okay, the second row, so load HR, and all this stuff has been generated based on that. But you just want to make sure that each of these corresponds. So load and power, they're basically the same thing. Heart rate is fine. Respiratory frequency is respiratory frequency. VE is VE. VCO2 is VCO2. VO2 and VO2. R and RQ are the same. VO2 heart rate, we don't have that. Fraction of end tidal O2 is the same. Fraction of end tidal CO2. VE VCO2. VE O2. SPO2, don't worry about it, that's the same. Revolution speed, they're the same, that's fine. End tidal CO2 is fine. End tidal O2. TI, TE, TTOT, VD, VT, dyspnea and leg pain. So that's all perfect, okay? You'd see that's being slightly different if oh, hang on, sorry. Just made one slight change there because something wasn't coming through correctly. So anyway, back to sheet 2. Okay, so you just need to confirm that all these things are the same, okay? Mainly these things here, this, and these two. That needs to copy that needs to be the same as that, okay? There's some kind of problem somewhere, okay? But normally they're okay. If you do those few checks that I gave you, I'll send you a photo of those few checks you have to do. And then this produces all this data here, okay? So it's the subject's ID, time, load, heart rate at rest, don't have it, frequency at rest, all these kind of things. These are the things I'm interested in. Okay, so the first one there is that peach color is all resting data. So we have to do two other things. We have to calculate the gas exchange threshold for this particular person, and we also need to calculate the max values, so our VO2 max for this person. These are all doing exercise tests on a bike. Okay, so the first thing we do is we're going to look for a gas exchange threshold, and we use this graph here, which is a V-slope graph, which you may have seen before. So I just highlight them and just have a look. So this is where it's pulling the data from. So this is a plot of VO2 against VCO2. And to forget the last few values, we want it to max, but when these people are doing exercise on the bike, it kind of comes a point where they stop exercising, but the test still records. So I'm looking for the highest value here. In this case, I'll go for the second last one. I look at load, so the load was still high there. That's the highest. I'd never take the last one because the mask might be coming off or something funny might be going on. So the load is still high there. The next thing I look at is the revolutions. That's how quickly they turn in the pedals, and that's 72. So what I'll actually do is, and I'm okay there actually, I'll go for that. Okay, so they're still turning the pedals there, and they've stopped, so that's all okay. Okay, so I'll mark this here as our max value, and the way I do that is just highlight across and click on red up here. Okay, next thing we have to do is identify gas exchange threshold. So that's kind of the point at which, so VO2 and VCO2 are related up to a point. So when you start exercising, basically at some point you start to produce more carbon dioxide than you do continue to increase more oxygen. You start to produce more CO2, and the production of CO2 is out of proportion to the consumption of oxygen. So you get this kind of kick pattern, this V-slope pattern, and that's what we're interested in. So each of these dots corresponds to a sample here. Okay, so if you can see, if you drag this all down to here, and this down to here, you'll be left with one spot up there. It should just be one. Sometimes it doesn't update correctly. It should just be one. Yeah. Okay, so just check that. So drag this all there. Doesn't matter if it was the first and the second one. So what we're looking for is two distinct lines, okay, and you can kind of see them here. Even if you just look at that, you can see that this kind of follows a linear pattern here. There's a lower slope, and when we get to about here, there's an upper slope, and you can kind of see it. There's two distinct slopes, what's called an S1 and an S2, okay, and these here, you're kind of looking for this bit here. Okay, trying to get as many of these dots as possible. There is a funny bit of a pattern going on here, which I often see, but there's definitely a distinct kick that takes place up here. So if you drag this in there, try and identify that point. So it's somewhere around here. So if you hover over one of these points, probably I tend to take the lowest one that's kicking up. So I go for that one there. So 111,832,979. So 1,111 and 979. So I see these two here. There's our 2 points. Okay, so that's gas exchange threshold. Quite subjective is what you're thinking. I think it is as well, but that's how it's done. So we'll identify that. That's our gas exchange threshold. Okay, so this is the green that we're going to fill in up here. So I copy this, and I also take a note of the cell number here. It's 52. I'm going to show you why in a minute. Okay, because we have to calculate the regression of that trend line. Okay, so copy that, and we know 52. So take this up here, control, and paste special, and paste link, because you're linking that data up. Okay, so that fills out there. And then we have to calculate the slope of that line. Okay, now the slope of the line is basically it's the slope all the way up to this point here. So it's this first slope, okay, before the kick, right? So we need to calculate where I need to enter in the point at which the slope is stopping, and remember that's 52. Okay, so that was here. Okay, so it's the slope of these 2 lines up to this point here, 52. Okay, so click into that, and let's change that from 76 to 52. And change this from 76 to 52. Click on enter. So that's the slope of that line up to that point. And then the intercept. So the intercept is the point that that line intersects the y-axis. Okay, again, I'll kind of illustrate this one a little bit better for you. So if I click on this, so double click into this, you'll see that we're calculating the slope of that. Okay, now the reason I put in 52 because I wanted to stop there. Okay, so it's basically what it's doing is it's calculating the slope of all these dots from there to there. Okay, it's just calculating that. This here is what's called S1. This here is what's called S2. It's kind of an S3 up here, so I'm not too concerned about that. So that's what we've done there. Okay, and then the intercept is doing a similar thing. It's calculating it's drawing a line of these 2 here, but it's calculating the point that this line, if it were to continue on beyond these points, where it would intercept that y-axis. Okay, and obviously that's dependent on how steep the line is. So if the line is really steep, then it might be a negative figure. So what's our intercept here? It's 2.13, so it's a positive figure. So it's actually, I think that's really healthy. Okay, and then finally we need our max data. So again, copy this, like that, take a note of that, 83. Right click, control, paste special, paste link. And then we have to do the same thing here, only this time we're going up to the max point. Okay, so remember that was 83. And this was 83. And then the intercept is 83. This is 83. And then the nadir is the lowest point, okay? And that, click to 83 there as well, and that's automatically calculated. Okay, so this is the nadir here, so it's the lowest, it's the point of, if you like, most efficient ventilation, and it generally corresponds to this, but I found that it isn't really. So yeah, so that's the last thing you do, and basically you're just telling it to look at all these points only up to there, and then take out the minimum point, and it highlights the minimum point. And then the last thing you have to do is look across here for the time that happens, highlight that neutral, and then just 2400, stick that in there, enter. And then all you do is you just save this, so file, save as, it's called EA096, so I'll file save as EA096, and we can underscore it, done, press enter, and save that somewhere else, and then you can go back and use the template file again. Okay, so that's your job. If you want to have a go, if you did 10 of them, that'd be fucking fantastic. Thank you, bye.